Okay, we are going to start talking about other 2D shapes besides circles. In this lesson, we're going to be focusing on triangles, trapezoids, and parallelograms. We're going to be talking about perimeter and area. Now, we've kind of talked about perimeter and area before, but just as a quick review, perimeter would be essentially the measure or the length of the outline of your shape. So in this rectangle I have, it would be all of these lengths put together, or the sum of those lengths. Same with the triangle. If we are trying to find the perimeter of a triangle, we would add the length of that side, and that side. Area is a little different. Area is basically the amount of space an object takes up. So in these cases, we're talking about the square units that these shapes are taking up. Okay, let's start with parallelograms. Now, before we actually get into area of parallelograms, I just wanted to review quickly what actually makes a parallelogram. So maybe pause the video, think about it. What is a parallelogram? So parallelogram, the common answers I got from your classmates was that they have four sides. And of those four sides, there are two sets of parallel sides. Meaning, if we look at the shapes here, we have parallel to this one, and this side would be parallel to this side. Now, what do we actually mean by parallel? Parallel is essentially when you have two lines that will never intersect, and they will only never intersect if they are at the exact same angle, right? So if these lines went on forever, they would never intersect because they are parallel. Okay, so parallelograms. Let's talk about what is a parallelogram besides having four sides and two sets of parallel sides. So I'm going to draw a couple different figures that make up parallelograms, or that are parallelograms. Okay, all three of these shapes would be considered parallelograms. We have a square. This side and this side would be parallel to each other, and these two sides would be parallel to each other. Same with the rectangle. We have those two sides that are parallel to each other and these two sides. So total we have four sides, and there's two sets of parallel sides. Same with the slanted one. This side is parallel to that side, and the top is parallel to the bottom. Okay. Now, what's cool about parallelograms is that if you do have two sets of parallel sides, and it's a four-sided figure, the opposite sides, so the parallel sides, will be equal to each other. So for example, if in this rectangle, if this left side is 4 meters long, the right side would also be 4 meters long. And if the top was 10 meters long, the bottom would also be 10 meters long. Same with the slanted one. The parallel sides would be equal in length to each other. So if the left side is 4 meters long, the right side would be 4 meters long. If the top is 10 meters, bottom would be 10 meters. Now with a square though, all sides are exactly the same size. So if we had, let's say, 5 meters on this side, this opposite one, the parallel one, would be 5 meters, but so would the top and the bottom. Okay. So with perimeter of a parallelogram, again, perimeter is just the length of the outline of your shape. Okay. So with every shape we talk about, whether it's triangles, circles, squares, trapezoids, octagons, whatever shape we talk about, the perimeter is still the same concept. You're going to add all the sides together. So find the sum of the sides, the sum of the measure of the sides. So let's maybe just kind of go over the examples that I've drawn before we get into area. Okay, for our lovely square, our perimeter here, again, is the sum of the measure of all the sides. So we could write it out as 5 plus 5 plus 5 plus 5. Another way of saying that would be 5 times 4. 5 times 4. Either way will give you the same answer of 20 meters. Now with our rectangle, or our slanted rectangle, I suppose you could call it, but it's just a parallelogram. We would do the same thing. Now I'm only going to add these once because they're the same measurements that I wrote down, 4 meters on the sides and 10 meter on the top and bottom. So the perimeter for both of these, again, we're just finding the sum of all the sides. So there's a couple different ways you could write it. We could write it just 4 plus 4 plus 10 plus 10. Right, we have 10, 10, 4, and 4. Another way you could write this, since there's 2 4s, you could say 2 times 4 plus 2 times 10. Another way you could say that, which pulls in distributive property, is 2 times 4 plus 10. And all of these would give you the same answer, right? If we add 4 and 10, we get 14, times 2 is 28. 2 times 4 is 8, 2 times 10 is 20, add those together, we get 28. 4 plus 4 is 8, 10 plus 10 is 20, add those together, we get 28. So all of those will give you the same answer. So I don't have a preference on which one you use, just use whichever one makes more sense to you. Okay, area though. Area again is the space a shape takes up, essentially. So we all should know by now the area of just a regular square or a regular rectangle, right? And the area of those, let me just get rid of some of this stuff here. Make sound effects while I do it, because who wouldn't want to make sound effects while they make things disappear? Ooh. Okay. What was it? Oh yeah, area. Okay. So we all know area of a square or area of a rectangle is essentially base times height. Base times height, or you could say length times width, but we're going to stick with base times height. So base times height, and it's the same for rectangles. We have our base, we have our height, we would multiply them together to get how much space it takes up. Okay, which makes sense because let's say we have this box right here. Notice how it's two boxes on this side and 3 boxes on this side. So together we have a total of 6 boxes, right? So 2 times 3 would be 6. Now you could just add it, right? 1 plus 1 plus 1 plus 1 plus 1 plus 1, but it'd be the same as multiplying. So that's kind of how we get the formula for the area of a rectangle or square. Base times height. Now, the tricky part is the slanted parallelogram that we see here. This one right here. Take a look though, because see this line right here? If we were to take this part and snap off that triangle, pick it up and move it over here, what we would have is a normal rectangle. Okay, this stuff wouldn't be here anymore, and we would be left with just a rectangle. So the area for any parallelogram, whether it's a square, a rectangle, a slanted parallelogram, any of those, the area will always be base times height, because you can always rearrange your object to make a rectangle. Okay, so it's always going to be base times height with parallelograms, with four-sided parallelograms, I should say. Okay, so base times height. Let's do an example. Okay, here we have a parallelogram. We have four sides. The top and the bottom are parallel, and the left and right sides are parallel. Now notice that the two sides that are labeled are both a length of s. And if they're s, we know that the parallel sides to those would also be s. And since all four sides are equal to a length of s, we know it's a square. All right. So to find the area, again, it's a parallelogram, it's a square. So typically, again, we would do base times height, base times height. In this case, we have s times s, and we know over here that s equals 7.4. So we could write this out as 7.4 multiplied by 7.4. Now another way you can write that, since it's multiplied by itself, you could say 7.4 squared. Okay, it'll get you the same answer. So if that makes more sense to you with squares, go for it. Either way though, when we do that, 7.4 squared or 7.4 times 7.4, we get a grand total of 54.76 units squared. Now I'm saying unit squared because it didn't actually give us a measurement like centimeters or inches or meters. So we would say unit squared. Perimeter. Perimeter, again, is when we take the sum of the length of all the sides. Now in this case, again, we could write it all out. 7.4 plus 7.4 plus 7.4 plus 7.4. But since they are all the same size, we can simply multiply 7.4 by 4, since there's 4 of them, 4 sides of that length. And we would get our perimeter of 29.6 units. And voila, we have the area and perimeter of a square. Now let's try another one. This one's a little more tricky. Now, before we actually do that one, let me draw you a couple pictures. Y'all know how I love my pictures. Okay. Now on this parallelogram, let's assume that this is our base. How would we know what the height is? Right? Would the height be this length? Is it this length? Where would our height be? So maybe think about that for a second. And the rule is, or I guess kind of a good way to remember what the height is or where the height is. The height will be perpendicular to, it's hard to spell long words while you're talking at the same time, perpendicular to the base. Now by perpendicular, I mean it intersects with the base at a 90-degree angle. So if that's our base and this is our height, this would have to be our height because it intersects at a 90-degree angle to the base. So if we look at this parallelogram, this does not intersect at a 90-degree angle, right? That's not 90. But what we could do is drop a line from one of these vertices, corners, drop a straight line down, and that would give us a 90-degree angle, and that would be our height. Now you could also draw it outside of your parallelogram, so that would be your height, because if we extended the base, it would be perpendicular to it. Okay. The reason I bring this up is because sometimes they'll try to trick you and draw like a weird sideways kind of, even more slanted, or maybe it's like almost looks like a diamond, right? So sometimes they'll try to trick you and just give you a bunch of measurements. So they may say like 10, they may draw a line and say 5. They'll give you this height over here, maybe this length over here, right? So they might give you numbers without saying, hey, this is the base, this is the height. So we would need to know how to find which is which. And again, the height will be perpendicular to the base. So if you see a line that's dropped and it's perpendicular to, so there's a 90-degree angle, a side, that would mean that that side is the base, and that length right there would be our height. Okay. Same with over here. If we dropped the line and it's perpendicular, that would mean this is our base, this is our height. Okay. All right, so here we have an example. Notice the variables that are being used. It doesn't matter what variable is being used. You need to actually look at your shape, find what's perpendicular to one of the sides, and that will help you identify the height and the base. So, where do you see a 90-degree angle? Well, here we see a 90-degree angle, which would actually make this our height. So the H is good there. And it would make C our base. Okay. Now, again, to find the area of a parallelogram, we do base times height. So if we rewrite this with the information we have from over here, our base, which is C, would be 9.3. And we would multiply that by our height, which they give us, and it is 4. So we would do 9.3 times 4 to get our area of this parallelogram of 37.2 units squared, or square units. Awesome. All right, let's do the perimeter. Again, perimeter, we are finding the sum of all the sides, all the lengths put together. Okay. Now, key thing again, they will probably not always label every side, but we know that since it's a parallelogram, we know that the parallel sides have to be equal. So this side has to be A, this would be C. So we do know the length of all the sides. So we can add it all together. Again, you can write it several different ways. I am going to write it as perimeter is equal to 2 times C plus A, because those are our sides. So in this case, C is equal to 9.3, and A is equal to 4.27. And we're not including the height here because it's not actually on the outline of our shape. Okay, it's part of the inside. We don't really care about that at the moment with perimeter. Okay, so if we do the math here, 9.3 plus 4.27, then we multiply the answer by 2, we would get our grand total of 27.14 units for a perimeter. All right. Triangles. Now, before, that was weird, before I actually get into the formulas for triangle, let me draw you another picture. Actually, I'm gonna actually use a ruler here. Whoa, right? Okay. So that looks a little bit more like an actual rectangle here. Okay, here we have a rectangle. Now, to find the area of a rectangle, we would do base times height. Now, if you take a close look, I want you to identify the type of shape we would have if I were to draw a line there. I'll just highlight the shape that we're looking at in blue. So all I did again was split. Oh, I just erased. All I did was split the rectangle in half diagonally. Okay. And what shape do we have? Well, we have a triangle. Now notice I said I split it in half. How mathematically do we split something in half? Well, there's a couple ways. We could divide by 2, or we can multiply it by a half, or multiply by 0.5. So the area then of a triangle, since a triangle is exactly half of a rectangle, the area of a triangle would be essentially the area of a rectangle cut in half. So there's 2 ways you could write it. You could write it base times height divided by 2. You could also write it half times base times height. Okay, and again, either one of these formulas work. They'll give you the same answer. So if you prefer one over the other, that's totally fine. Okay, now there are different types of triangles. Let me come over here and draw some more pictures for you. We have what we call a right triangle, which has a right angle. We could have something like an equilateral triangle, meaning all sides are the same length. And we could have some wonky triangles. I'm actually going to read out that one. Okay. So again, what we need to find the area of a triangle would be base and height. So I want to again go over how to identify base and height. And it's the same rule as, or it's the same kind of trick as before. The height will be perpendicular to the base. Okay. So again, what would we be looking for is that 90-degree angle. Since this line and this line intersect at a 90-degree angle, we know that one of them is the base and one of them is the height. Now, it doesn't really matter which one's which in this case because we're multiplying them, and according to commutative property, we can multiply in any order and we'd get the same answer. So we have our base and our height. Now, let's say we're looking at this equilateral triangle. And let's say that that's the base. Where would our height be? Well, if that's our base, our height would have to be the line that intersects the base at a perpendicularly way. That was not a fantastic way of wording that. Grammar. The height will intersect the base perpendicularly. But it also has to go from the highest point of our triangle. So it couldn't just go like that because, yes, that's perpendicular, but we don't know where the top of our triangle is. Okay. So we're going to go from basically the tip of our triangle, drop a line that's perpendicular to the base, and voila, we have our height. Now the next two are a little weird. Okay. Let's assume that this is our base. Where would our height be? Now, you'll notice, again, we could draw lines perpendicular to the base anywhere, but that wouldn't really give us how tall our triangle is. So you would again do the same thing. Go to the highest point of the triangle there and drop a line that would be perpendicular to the base if it were extended. Okay. And that would give us our height. Okay. And this works even though it's a weird slant there, this formula still works because imagine if we doubled this weird shape. If we doubled this weird shape, you would have a parallelogram, right? And area of a parallelogram is still base times height. So that formula, base times height divided by 2 for this weird wonky triangle, would still work. What about this one though? Now, just looking at it, we wouldn't be able to tell what's base and height because, I mean, you could draw a line perpendicular to this base. You could draw a line that's perpendicular to this base. You could also draw lines perpendicular to this base, right? So you will be given some kind of information, whether it's just a line or it actually says, hey, this is the base, or hey, this is the height. So you will be given some kind of information that tells you what's base, what's height. Okay, now that we know base and height of triangles, again, I would write those triangle area formulas down if you didn't already, those blue ones there. And let's try an example. Okay, so let's first identify which is the base, which is the height for area. Because again, area of a triangle would be base times height divided by 2, or you could do 1/2 times base times height. Again, the key thing with height is that it will be perpendicular to the base. So you're looking for that 90-degree angle. So this line right here, since it's perpendicular to one of the sides of the triangle, that would mean that this is our height. And it means that this right here would be our base. Now, since we are given the information, we can actually find the area. And we want to use C and H for that. And we would just substitute what we know into our formula. So base times height, in this case, would be 8.1 times 4.4. And then we would divide it by 2. So if we were to do that, 8.1 times 4.4, we get 35.64 divided by 2 because it's not a rectangle, it's a triangle. And we get our area of 17.82 square units. Awesome. Now perimeter, again, is the same concept. We are finding the sum of the length of all the sides of our shape. And again, we don't include height because it's not on the outside of our shape. We're just looking at the length of the outline of our shape. So in this case, we are doing A plus B plus C. And we know that A is 4.92. We know that B is 7.36. And we know that C is 8.1. So if we were to add all of those together, 4.92 plus 7.36 plus 8.1, we would get a grand total of 20.38 units. Sweet. Okay, the slightly more complicated one, trapezoids. Before we jump into the formulas for trapezoids, just like parallelograms, I wanted to go over kind of what makes a trapezoid. What is a trapezoid? So a trapezoid also has 4 sides, but this time only one set of parallel lines. Okay, so there could be various trapezoids drawn. So we could have one where these two sides are the same length, so like 4 and 4, but the top and bottom would not be the same length because again, they're slanted at different angles, which makes this length right here shorter than this length right here. Okay, not necessarily half the length, I just chose random numbers. You could also have a trapezoid that looks a little more wonky, or maybe one that has one really long side and one pretty short side. Okay. Now, the perimeter of a trapezoid would still be the same concept again. We're adding the length of all the sides, so that doesn't change. The area, though, is a little different. The area of a trapezoid is going to be basically your two parallel sides. We call them bases. So if these are our parallel sides, we would call that one of the bases. You could call it base 1, and you could call that base 2. You could also just call it side A, side B, or side X and Y, or any variables you want. So for the area of our trapezoids, again, just like triangles, we can write it a couple different ways. So I'll give you both of them. Essentially what we're doing is adding our two bases together. So the length of base 1 plus the length of base 2. We're multiplying it by the height. So think of base times height, only in this case we have two bases that we have to add together. And then we would divide it by 2. So it's still kind of like base times height divided by 2, only in this case we have two different size bases, so we have to add them together first. And again, you could also write it as, instead of divided by 2, you could write 1/2 times base 1 plus base 2 times height. So again, 1/2 times base times height, only in this case we have two different size bases, so we have to add them first. Okay. So again, it's important to know how to find the base and which is your height. So we're going to abide by that same rule. Height's going to be perpendicular to the base. So in this case, it's going to be a perpendicular line that connects one base to another base, since we have two different bases with trapezoids. So if we have a base right here on the bottom and a base right here at the top, a perpendicular line that connects those two would be something like that, right? And on this next one, we'd have to first look for the bases. And again, the bases are going to be the set of parallel the set of parallel lines. So that is definitely not parallel to that. This is parallel to this though. So we have one of our bases, we have another base, which makes our height the one that connects those two bases perpendicularly. And it just so happens that that side right there is a 90-degree angle to it. The next one's slightly more wonky. These two sides are definitely not parallel, right? They're not slanted at the same angle, but these two lines are parallel. So we could have one of our bases, our other base, and our height would be the one that, again, connects those two lines in a perpendicular fashion. So you could drop a perpendicular line there. You could also put it there. Same with on this one, you could put it over there or over here. Okay, it's just going to be a line that connects the two bases in a perpendicular fashion. Okay, so now that we have that all figured out, let's try an example. And again, just like the other ones, we're going to first identify what's the base and what's the height. Again, the bases are going to be the ones that are perpendicular to each other. So they're slanted at the same angle, right? Which means this and this, they are not slanted at the same angle. If you kept going on forever, they would eventually intersect, which we don't want. But if we look at the other two sides, A2 here and A1 here, those are parallel, which makes this one of our bases. We'll call it maybe base 1. And this would be our second base, base 2. Our height then would be the line that connects those two in a perpendicular fashion, which would be this line right here. Well, that's actually called H, which is convenient. All right, I'm going to write the formula for the area of a trapezoid first. So area, we're going to have base 1 plus base 2 multiplied by height and divided by 2. Again, if you're more comfortable with base plus base times height times 1/2, that's totally fine. It'll give you the same answer. All right, let's substitute what we know into our formula. We know the two bases. Base 1, which is A1, is 15 units. We're going to add that to base 2, which is A2, and that would be 10. Our height, which is H, is going to be 4.5. And whatever that answer is, we are going to divide it by 2. So step by step, we would have 15 plus 10, which is 25, times 4.5 gives us 112.5. Then we would divide by 2 to get our grand total for the area of 56.25 square units. Awesome. Okay, last thing, perimeter. Again, perimeter, same concept. We are adding the length of the outside of our shape. So we don't care about H that's inside of our shape right now. We're just adding B1, A2, B2, and A1. So essentially we are taking these numbers right here and finding the sum of them. If we do that, we would get a grand total of 36 units for our perimeter. Fantastic. All right. Now you're going to do some practice. That was strange. I will put this in the directions on Google Classroom, but I want you to do half of the problems on the front and half of the problems on the back. So you don't need to do all of them. Half the problems on the front and half the problems on the back. And I would challenge you to make sure you actually do try one of the trapezoid ones. practicing those is very useful. Be sure to show your work on those. By show your work, I simply mean you can write out the formula. You don't have to write out step by step, so you wouldn't have to write like 25 times 4.5 divided by 2 next, and then we would have 112.5 divided by 2, blah, blah, blah. You can just write this formula. So basically, you're just writing down what you're putting into your calculator. Okay, when you're done, turn it in. And if you have any questions, as always, please ask.